Hi guys, welcome to Unshackling Sudokus and Puzzles. I'm Kishore and today I'm going to solve a hybrid Sudoku. This Sudoku was created by Sudoku Nim and it is titled Careful Whispers. This Sudoku has a combination of three variant rules involved. So, if you want to try the Sudoku yourself, the link to solve is given in the description of the video. Now, let us move on to the rules of the Sudoku. Normal classic rules apply. In addition to that, you have killer rules. So in each of these cells encompassed by dotted lines, the sum of the digits is given at the top left corner of the cage and digits do not repeat within a cage. So this is the killer part. The second part is anti-knight. So digits connected by a knight's move cannot have the same digit. So a knight moves two steps in one of the direction and one step in the perpendicular direction. So for example, if you consider this 7, all the yellow cells or the knight steps away, all the yellow cells or knight steps away from this 7. So 7 cannot be in any of these yellow cells. So this property works for each and every cell in the grid. So this is the anti-knight property, and the final part is the German whisper rule. So in each of these dark red lines that you see, the adjacent digits differ by at least 5. So this is the German whisper rule. So we have the killer rule, we have the anti-knight rule, and we have the German whisper rule. So it's a triple hybrid variant. So let us see how it goes. Seems to be a really interesting one. And before we start solving, please do hit the subscribe button below and subscribe to the channel. We'd be really happy if you subscribe to the channel now. So let us start the Sudoku. Okay, does the killer help us? Okay, this cage helps us, right? Because 14 can only be 5 plus 9 or 6 plus 8. 6 plus 8 is ruled out. So which means this has to be 5 and 9. So we got going there. And if you look at this 11 cage, it cannot be 3 and 8. It cannot be 5 and 6. So there are only two possibilities to fill this 11 I mean. 2 plus 9 or 4 plus 7. Right? These are the only candidates that can go inside the 11 cage. But we know that a 7 cannot be present in this cell because it's at a knight step away. So we'll need to remember all the three simultaneously to eliminate possibilities. So 7 is not going here. 7 is removed from here and correspondingly 4 gets removed from here. Nice. So we got the possibility for 11. Okay. And if I look at this 9 cage, it cannot be 1 plus 8. It cannot be 3 plus 6. So it has to be either 7 plus 2 or 4 plus 5. There are only 4 possible sum combinations for 9 when it is a 2 cell cage. So we have written all the possibilities inside the 9 cage. And I don't think we can eliminate any digit from here. So let us look at the 11 cage in box 4. So it cannot be 3 plus 8. And because this cell is at a knight step away from 6, it also cannot be 5 plus 6. So again only two possibilities for 11. Either 2 plus 9 or it is 4 plus 7, right? Only two possibilities, but this 7 is at a knight step away from here, so this is not a 7, which means this is not a 4. So these are the exhaustive list of possibilities that can go inside these cages. Okay, using simple classic, we can get a 6 here because these two cells are not 6, which means that using classic we could get the 6 here. And now we can place, try to write some candidates inside this 11. It cannot be 3 plus 8, it cannot be 5 plus 6. So only two possible sum combinations exist for the 11, right? It is either 2 plus 9, 2 plus 9 or 4 plus 7, right? Only two combinations. So 8 in box 4 goes in either this cell or this cell. It cannot go in either of these cages. So 8 goes in one of these cells. Okay, do we need to start looking at the German whisper part? We haven't yet looked at it, but there are very few cages and very few digits too to make use of the uh, this one anti-night part. Okay, again using classic and anti-night we could place a digit, guys. 3 cannot be in row 4, 3 cannot be in row 5, and anti-night rule eliminates the 3 from these two cells, right? Because 3 is at a night step away from this cell, 2 steps in one direction and 1 step in the perpendicular direction, and similarly 2 steps in one direction and 1 step in the perpendicular direction, or even you can go 1 step in one of the directions and 2 step in other direction, right? So 3 is removed from this cell, so this is not a 3, right? These two cells are not 3. Okay, so we got one more 3 in the grid. Okay, so let me write some more digits here. So we have 3, 5, 6, 9 in column 8, which means that this cell can only be 1, 2, 4, 7, 8. And now for people who are familiar with German whispers, we can surely eliminate 4 or a 6 in the middle of the line, because we know that the difference is at least 5 between adjacent cells. So if you have a 4 in the middle of the line, then both of the nearby cells must at least have 9, and which is clearly not possible here, right? If you have a 4, both these digits become 9 at least, and that's not possible. So 4 is removed from here, and rest of the digits are very much possible. They can be 1, 2, 7, 8. So 3 is also not here due to the night rule. 6 is not here because of the anti-night rule. Okay, if I have a 6 here, this becomes 1. That's not a problem. Oh, this is really nice, guys. Superb. So we could have deduced these two sum combinations the moment we wrote down all the possibilities here. So you will notice that the 9 cannot be 2 plus 7. We have written that 9 is either 2 plus 7 or 4 plus 5. So if it is 2 plus 7, then there is no sum combination left for the 11. It cannot be 2 and 9, it cannot be 3 and 8, it cannot be 5 and 6, and it cannot be 4 and 7. So this cannot be 2, 7. Beautiful. So we can remove the 2 from that cell and 7 from that cell. So it has to be 4 plus 5. And that removes the 4 from here, which in turn removes the 7 from here. So we have got down both of these possibilities, which means these would be 5, 8 pair for the box. Sorry, 1, 3, 6, 4, 5, 2, 9. So 7, 8, and 7 cannot be here. So this would have to be 8 and 8, and that would have to be a 7. And you have 7 here, which means this is not a 7, it's at a night step away, and correspondingly this is not a 4. Okay, using classic I get 7 in one of these two cells. I have a 2, 9 pair here. Okay, in row 5. So if I look at this cell and ask myself what are the candidates which can go there, 2, 9, 3, 6 and 7 are eliminated. So this can only be 1, 4, 5 and 8. And you have a 1 here, so that's not a 1, so that's 4, 5 and 8. Okay, I'm just looking at cells which can take only minimum candidates. Okay, look at row 4 and these two cells, column 7, column 9. So 1, 3, 6, 7 and 2 and 9 are eliminated. So these two cells must be 4, 5, 8. So if I look at this row, okay, 2, 9 must go in one of these two cells. Wow, this is beautiful, guys. Superb. Superb deduction. And this is a live solve. So I just wanted to add that point. So if you have a 2 here, what happens? You can't have a 2 here, so this gives the 2 here. Now 2 is removed from both of these cells. And similarly, if you have a 9 here, 9 is removed from this cell due to the anti-night property, and this becomes 9, and again 9 is removed here. So which means that this cell cannot be 2 and 9, and we just established that 2 9 must go into one of these two cells. So which means that this would have to be a 2 9. That's a lovely deduction, really nice. So we can make use of that, I think, which means this has to be 4 5 8 for the row. Okay, that's nice, guys, really nice. So I have a 2 9 pair in row 5, and I know that in box 5 I need to write 2 9 somewhere, right? I have written 2 9 here, and none of these 5 cells can contain 2 9. None of these 6 cells, in fact, right? None of these cells can take a 2 9 because of the 2 9 pair here. 2 9 is removed from here, which means either this cell is 2 or 9 or this cell is 2 or 9. But can this be 2 or 9? What happens if you take 2 or 9 here? If you have a 2 here, 2 is removed from both of these cells because of the night rule. And if you have a 9 here, 9 is removed from both of these cells again because of the classic and night rule. So 2 9 cannot go here, which means this would have to be a 2 9. Really nice. And 1 has to go either in this cell or this cell. Just two options for the 1. So if I look at row 6, I have 2, 6, 7, 9, 3 and 8. And the remaining candidates must be 1, 4 and 5. So this has to be 1, 4, 5 and this has to be 1, 4 and 5. And one more small deduction that we can make is that a 5 can never be in a German whisper line. This could have been made earlier to reduce the 5 in this cell. I just got it now. So if you have a 5 in a German whisper line, you need to either have 0 or 10 as one of the digits in the Sudoku, which is clearly not possible. So if you look at row 8, 5 can never be in this line because minimum difference must be 5, and which means that 5 in row 8 must go in one of these 5 cells. But we have a 5 9 pair here, which means this cannot be a 5. So this has to be a 9 and that becomes a 5. So we got the 5 for row 8. And similarly we could get the 5 for row 2. So 5 goes in one of these two cells, but you have a 4 5 pair here, so that's not a 5, which means this would be a 5. And 5 for column 2 now goes in one of these two cells. Okay, so if you look at this 5 carefully, it eliminates the 5 from these two cells because of the night rule. And now in column 5, 5 can go only into these two cells. 5 cannot be in German whisper lines. So 5 in column 5 goes into one of these two cells. Okay. So I need to think what happens in these lines and these lines. So you have a 9 here, which means 9 must go into one of these lines. Okay. And if you have a 9, you can have success the adjacent cell as 1, 2, 3 or 4. So nothing helpful there. Okay. So what am I missing here? And 9 is not really a super helpful digit when it comes to German whisper lines, right? Because like I said, this adjacent cell can be 1, 2, 3 or 4. However, 4 and 6 are really helpful because if you have 4 or 6 anywhere on the line, the adjacent cell can only be 9 and 1 respectively. Oh, kind of an unorthodox direction, you can say. So I just happened to hit on this direction. So look at this cell. This cannot be any of the digits which go inside these cells, right? Because if you have this cell, or a simpler way to say is the blue cell, whatever goes into the blue cells gets eliminated due to classic from these three cells, and gets eliminated due to anti-night, because these two cells are at a night step away from this cell, which means that this cell can only be 2, 3, 6 or 9, nothing else. Because if it's any of the other cells, then this blue cell will take an anti-night clash, rule clash. So this can only be 2, 3, 6 or 9, right? If you have 1, 4, 5, 7, 8 here, it would either be at a night step away or it will just clash with the classic part. So this is 2, 3, 6 and 9. Interesting, guys. This is really interesting. 3, 6, 7, 2 and 9. So this is going to be 1, 4, 5 and 8. Okay, but I don't see any purpose to mark a pencil mark there, because just not helping. Can this be a 2, 9? This is either 2 plus 9 or 4 plus 7, right? If it is a 2 or a 9, gets removed from the cell and it goes here. Okay, nothing there. Okay, let me write some candidates, guys. I'm not seeing anything here. So you have 4, 5, 7 eliminated from here and 3 eliminated from here, which means that this is 1, 2, 6, 8 and 9. Is there any 6 is eliminated from that cell, guys? Quickly, because if you have 6 here, what happens is that this has to be a 1, because like I said, if you have 4 or 9 in the German whisper line, always be on the lookout for where 4 and 6 can go on the whisper line, because it will really help you. So if you have a 6 in this cell, then this cell will invariably have to be a 1, but that is not possible. So 6 is ruled out from here. And 6 cannot be here as well, because again 1 is here. Is 6 is, okay, 6 is helping us. Beautiful. So we know that 6 in row 8 is eliminated from these two cells. It's just coincidental that I noted the point that always be on the lookout for 4 and 6. So 6 is eliminated from these two cells due to the German whisper rule, right? And we saw that 6 cannot be here and 6 cannot be here, because that would require a 1 here, which means that 6 can only be in these three cells, but 6 is already eliminated here, which means 6 is either here or here, and that means that this would have to be a 1. Nice. So that eliminates the 1 from this cell. That's not 1. That's a 4 and 5. So you have a 4, 5 pair here, which means this would be a 1. And 1 in box 5 has only one cell left. This has to be a 1. And now, okay, does the 1 help us? 1 cannot be in these three cells due to the night rule, and 1 cannot go here, so 1 has to go here. And that eliminates the 1 from here, so that's not a 1. So this is 2, 7, 8. 1 is eliminated from here, classic. And 1 in row 9 has only 2 cells left. 1 cannot go here because of the night rule, so 1 goes here. And that gives 1 in one of these two cells. And 1 cannot be here in column 6, 1 cannot be here in column 5, so 1 is in one of these three cells. And because 1 is going in one of these two cells, you can eliminate the 1 from these two cells. This is a common L-shaped idea of the night rule, right? So L-shaped idea is nothing but when you restrict the possibility of a candidate to two cells in an anti-night Sudoku, the cell which makes the L shape, right, cannot take the same digit, right? Because if you have one in these purple cells, or what is this color, blue cells, so if you have one here, one is removed from this cell and this cell, and similarly if you have one here, one is removed from this cell and this cell, so which means these two cells cannot be one and this would have to be a 1. And let us continue with the ones. 1 in column 7 has 3 cells left. It would go in these 3 cells. This cannot be a 1. Okay, fine. And so let us look at this cell. The minimum difference must be 5, which means that this has to be 6, 7, 8 or 9, and you can't have 6, 7 here, so that is 8 and 9. And because you have 8, 9 here, so in one more small thing about a German whisper rule is that uh, if the first digit, it will have groupings of digits. For example, if the first uh, digit on the line is from the digits 1, 2, 3, 4, the next digit on the line would be from the digit 6, 7, 8, 9. So this is invariable. So now we have group digits from the grouping 6, 7, 8, 9. So which means this would be from the grouping 1, 2, 3, 4. 1 is already here, so this is 2, 3, 4. That giving me something? Not really. Let us look at this one, guys. So which means these two cells must be 6, 7, 8, 9 and 6, 7, 8, 9, because minimum difference must be 5. 7 is eliminated from these two cells due to the night part, so 6, 8, 9. And 9 is here, so 9 is eliminated from here, so 6 and 8. That's really close. If we had removed one more digit, that would have been really good. Okay, look at this 3. 3 is removed from all these 3 cells. 3 is already not here, so 3 is going in one of these green cells, right? Let me remove the highlights. There are too many highlighted cells now. So 3 is in one of these two cells. Okay, this is beautiful, guys. Just what we did here. In row 8, we found where the 6 can go. Just check in row 2 where the 6 can go. 6 cannot be here. And because if you have 6 in one of these two cells, then 6 must go, then 1 must go here, which is not a possibility. So in row 2, we have exactly one cell left for the 6. So this would have to be a 6. And 6 in column 3 goes here. 6 is eliminated from here because 6 is here. And 6 is eliminated from this cell due to the night rule. So that's 6. Okay, so these two cells for the column cannot be 2, 6, 8, 9 and 1 and 5. So they can only be 3, 4 and 7. And 7 is eliminated from here. Night rule. So this is 3 or 4. There must be something really good here. Just checking on. Wow, this is good, guys. Slightly deep deduction, you can say. Just let me see that once more. Okay, so that is for sure. This is a really nice deduction. I can say for sure that these two cells will be from the grouping 6, 7, 8 and 9. And why am I saying that with conviction? Because if these two cells are from the grouping 1, 2, 3, 4, I hope you guys are able to follow what I say when I mention grouping continuously. Grouping, as I mentioned, is nothing but successive cells will have one digit from the grouping 1, 2, 3, 4 and another digit from the grouping 6, 7, 8 and 9. That's how a German whisper Sudoku works. So if these two cells are from 2, 1, 2, 3, 4, you have 1 here and 3 is removing the anti-night part. So these two cells become 2, 4, and which means that this cell would have to be a 9 minimum. Because of the 4 here, this becomes 9, but 9 is ruled out. So now it's certain to me that these two cells would be 6, 7, 8, 9. Beautiful. Nice deduction. So you have a 6 here, which means these would be 7, 8 and 9. And because the minimum difference must be 2, must be 5. So these cannot be 7 and 8. So that is a 2. And this is 3, 4 now. 2 is removed from there. This is not 2. This is 4 and 9. And that is not a 9. Because 11, they need to add up to 11. Okay. So I have 7, 8, 9 triplet in row 3. So this has to be a 4. Which means this becomes a 7. And now using classic, I get the 7 in column 3. So that's a 7. And because the difference has to be minimum 5, this would have to be a 2. And this has to be 8 and 9. And if you look at row 8, I have 6, 8 here, 6, 8, 9 here and 8 and 9 here. So I have a triplet 6, 8, 9 and 1, 2, 5, 7, which means these two cells must be a 3, 4 pair. Okay, so in column 3, 4 has exactly one cell left, this cell. So this would have to be the 4. And using night rule, I can remove the 4 from this cell. So that is a 5, which means that is a 4. And this 5 gives me a 4 here. And 4 is removed from this cell and this cell. So these would be 5, 8 pair. Okay, so let me fill the digits in column 3. I have 2, 5, 9 and 4, 6, 7, 8. So these would be 1 and 3. So 1, 3, 5 and 4, 6 and 7. So these have to be 2, 8 and 9. And this 2 removes the 2 from this cell. So that is 8 and 9. So if I look at column 1, 3 has exactly one cell left. So this would have to be the 3. And these would be 5, 8 and 9. I have a 9 here. So 9 is removed from here. And I have an 8 here. So 8 is removed from here. Anti-night, right? Okay, so 4 is here. So this has to be a 3. And 3 in column 4 has only one cell left. So 3 goes here. This is a nice Sudoku, guys. I'm really loving it. I have 1, 3, 6, 2 and 9 here. So these would be 4, 5, 7, 8. So 4 cannot be here. So they have to be 5, 7, 8. And 5 is ruled out. So this is 7, 8. Okay, 8 is also ruled out. This is a beautiful deduction, guys. If you have 8 here in this yellow cell, 8 is removed from this cell and this cell because of the night rule and classic. But both the 8s get removed. That's not possible. So this cannot be an 8. That is a 7. And that is 5, 8. So 2, 3, 6, 7, 1, 5 and 9, 1, 5, 9. So this would be 4 and 8. So I have 4, 8 here, which means 8 is removed from the horizontal line. So these become 7, 9 now, and that has to be an 8. And that 8 removes the 8 from here. So this is 5, and that becomes 8 now. And that 8 gives a 5 here. And these would be a 4, 8 pair. So probably the anti-night will help us at this stage. Maybe so we have 2, 9 pair here. So that's not 9. That is a 7 and that is a 9. So if you look at the German whisper lines, you will see that the successive digits differ by at least 5. So this is not 9. 2, 4, 8, 7 and 9. So remaining digits are 1, 3, 5 and 6. And 1 and 5 cannot go in these cells. So I get a pair. So 1, 5 pair. and these two cells must be 3 and 6, right? Sorry, 3 6 and 3 6. So this 3 6 pair resolves this 3 4 pair. Okay, so that is a 4 and that is a 3, and that 4 resolves this 4 8 pair. That is a 4, that is an 8. 1 4 5 8 3 6 and 9, so I get 2 7 here, and which can be quickly resolved. So that is a 2, that is a 7, and these two cells must be 6 8 for the box, and you have 6 here, which means this has to be a 6, that has to be 8, and using classic I get the 5 here, and 5 is in one of these two cells, so 5 goes here. 1 3 5 6 7 8 9, so these would be 2 and 4. Okay, this is 8 and 9 for the box. Okay, now I can just finish up this 2 9 pairs, guys. Because of this 2, you can't have 2 here, so this would be a 9, that is a 2, that is a 9, that is a 2, that is a 9, and that is a 2, and that resolves this 2 4 pair, so that is a 2, that is 4, and you have 9 here, so this is not a 9, so that has to be 6, that has to be 8 using pencil marks that we have made, so that would be 8 and that would be 9, so these become a 2 8 pair, and that would have to be a 9. 1 2 5 3 6 7 8, so the 4 9 pair in column 5, so 9 is here, so that's a 9, that is 4, that is 4, that is 8, all classic stuff, 8 2, and 2 in box 2 has only one cell. 1 2 8 9 and 3 and 4, so 5 cannot be here, so that is a 5, and that resolves this 1 5 pair, so that's a 5, that's 1, that is 1, that is 3, that is 3, that is 6, 3 4 8 9 1 2 5, so this has to be 6 and 7, and the remaining digits are 3 7 and 9, so this would be 7, that would be 9, and with that we have completed this really gorgeous construction by Sudoku Nim. It combined three variants fantastically, and I think the break-in was finding where the 6 goes in row 8 and row 2. That really helped us in the solve. Hope you guys really enjoyed watching me solve this Sudoku. Please let us know your thoughts in comments, and do remember to hit the subscribe button under the video. We hope to see you soon with a video. Take care until then. Bye bye.